Exponent rules, easy version. This is just going to be going over what are all of our different exponent rules, and we're only going to be using them one rule at a time, not mixing them. So the first one, multiplying by the same base. Remember, our base is the number down here. This is my exponent, c to the third power times c to the fourth power. Well, what that means is I have c and I'm going to multiply it times itself 3 times. And then c to the fourth power means I'm going to take a c and I'm going to multiply it by itself 4 times. So when I put it all together, I see that I have the same base of c. And how many times did I multiply it together? Well, 1, 2, 3, 4, 5, 6, 7. So that would be c to the 7th power. When I look at my rule, anytime I'm multiplying the same base, the rule says just add our exponents. Well, 3 plus 4 is 7. So using the rule makes it simpler, so I don't have to go ahead and write it out. The next one, d to the 5th divided by d to the 2nd. Well, if I were to write it out, that means that I would have 5 d's that I multiplied as my numerator, and then I have 2 d's as my denominator. Anytime I have the same number on top and bottom, they are going to cancel out. So when I'm left with that, I see that I only have 3 d's left on top. So d to the 3rd power. Now my rule over here says that anytime I'm dividing quotient of powers, remember quotient is just the answer to a division problem, it says to go ahead and subtract your numerator exponent by your denominator exponent. Order matters when I'm subtracting, so be careful. We're going to see later on where if I get a negative number, there's something else I have to do here. So 5 minus 2 is 3. So this was my answer using the rule and by writing it out. Power of a power. Well, let's first see, what does this really mean? K to the 4th power, and then I'm raising all of that to the 3rd power. So here is my base, k to the 4th power. K to the 4th power, and I'm going to do that 3 times. So I'm going to have k to the 4th times k to the 4th times another k to the 4th. Well, if you go back and you remember our rules while ago on when we're multiplying, it said to add. Well, 4 plus 4 plus 4 is 12. So whenever I'm solving this, how many k's do I really have? I have k to the 12th power. My rule says when you're raising something to a power of an exponent, you're multiplying the exponents together. 4 times 3 is indeed 12. Please do not get this rule confused with your multiplying the same base. This is raising it to a power. Negative exponents. Usually we don't see a lot of negative exponents, but when we do see a negative exponent, I need to simplify it. What it really means is change its location in the fraction, and then we get rid of the negative sign. So right here we have a to the negative nth power. Well, if I wrote it as a fraction, it would be over 1. To get rid of that negative exponent, all you do is you move it to the different location. So move it to the denominator, and that gets rid of the negative sign. But the base and the exponent stay the same. So what about on this one, g to the negative 2nd power? To get rid of that negative exponent, I need to move its location. I'm going to move that g, and when I change its location, it gets rid of the negative sign. Now, since I have a fraction, I don't have anything on top. I need to go ahead and write a 1 there as a place filler. So 1 over g squared is our answer. Let's do another example. This time I have a number written as a fraction. I have a negative exponent. It's on the bottom. So to get rid of it, all I need to do is move its location. It's going to move to the top. The 3 stays 3. I'm not doing anything with my 3. And then the g to the 4th power. And when I move its location, I get rid of the negative sign. So I really don't even have a fraction anymore here because there's nothing left on bottom but a 1. Rational exponents. This is probably the least used rule that we use in Algebra 1, but it's important that you at least know what it looks like. This is when you have an exponent that is a fraction. So let's see what it says to do. We're going to end up changing it to a radical symbol. So we have our square root sign, and our numerator, whatever that exponent is on the numerator, it's going to stay the exponent on the base. My denominator is going to change to a little number on the outside, telling us whether we're going to be square rooting, cube rooting, or what. So let's look at this problem right here. It's a fraction, so I know it's going to be written as a radical sign. My base stays, so the h is my base. The base stays and it goes inside. My numerator is going to be its new exponent. So my numerator here would be a 3, and that's the exponent I'm going to write. My denominator is going to turn to the number on the outside. That's going to be a 2. So that is telling me that we are square rooting h to the 3rd power. Now, could we go ahead and take this and write it with a fraction exponent? Well, my base is going to stay my base. Remember, this number out here, that's going to become your numerator. And our number on the outside, that's going to become our denominator. So these two are equivalent, just different ways of writing them, whether we have an exponent as a fraction or not. So now let's go ahead and practice everything that we just did. Go ahead and hit pause and see if you can solve all 4 of these problems, and then hit play and see how you did. The first one, we are multiplying. So we're going to use our product of powers, and it says we're adding our exponents. So our base stays the same of b. 5 plus 3 is 8. So if you got b to the 8th power, great job. On this one, we are raising it to the power of 7. So when I'm power of a power, that means I'm multiplying my exponents. So our base stays m. 3 times 7 is 21. So if you got m to the power of 21, great job. Down here, now this one I made a little bit trickier and everything. We're dividing, so it's going to be my quotient of powers, and it says to subtract numerator divided by denominator. So let's go ahead and do that. When I subtract, I get 3 minus 7. Well, 3 minus 7 is negative 4. But wait, can I have a negative exponent? No, I need to change its location. Now, if I wrote it as a fraction, I can see that that is my numerator. So now I need to change its location, and it's going to change to the bottom. It's going to change to my denominator, and I get rid of that negative sign. Now, I don't have anything on top, so I need to put a 1 as a placeholder. So the correct answer for this first one, if we solved it correctly, is 1 over r to the 4th power. And remember, when in doubt, write it out. I have 3 r's on top and 7 r's on bottom. I know once they cancel out, I'm going to have more r's, and they are going to be on bottom. And let's try our last one. Multiplying a base times another base. So this rule right here, product of powers. When I solve it, I'm going to get a 5 times negative 8 is negative 40. Oh, wait, once again, I cannot have a negative exponent, so I need to go ahead and change its location. So it's going to move to my denominator, a to the 40th power. I'm going to put a 1 on top as a placeholder. So it is a fraction, 1 over a to the 40th power. Remember to use your rules, and when in doubt, write it out.